In its simplest form, DevOps is a way of having a completely automated pipeline for CI and CD, where we are able to reliably and rapidly deploy applications at a managed infrastructure with a consistent repeatability. I can do this CI and CD with a simple bash script, but will it be optimum? No. Will it be production grade? No, and it definitely will not be secure or scalable. And that's why we have modern day tools that help us get the security, the reliability, the consistency in our CI and CD pipelines. However, if you see the list of tools that are available in the market, you will quickly realize that it is humanly not possible to know all of these tools. There are so many options that you can't even count how many CI and CD tools are coming every year. So the most logical question that comes in one's mind is which tool to pick, which tool to use, and which tool to ignore. Now, one important parameter for you to consider while making this decision is to know what lies ahead in terms of future tasks. If you are in an organization and you know that your organization is going in one particular way, then you can pick and choose the tools based on that organization's requirement. If you want to broaden your vision and you want to not only choose the tools based on what your companies might need, and you want to see what is the generic future that lies ahead for the entire IT industry, then it becomes absolutely critical for you to know the future tech or to know in which direction the big giants are investing their money in. That is the precise point of having this video. I am trying to give you my analysis, my perspective of this very topic. What lies ahead in terms of a future for the next coming decade for a DevOps engineer, and where should you invest your time and energy in. Don't get me wrong, I'm not trying to predict the future. It's beyond me. I can't do that. But if you look at the current tech giants, where they are pumping and pushing all of their money, all of their capital investments, you can make a safe bet and assumption of what the future tech is going to be like. If you look back and you try to connect the dots, you can see how internet boom happened and how communication boom happened and how different devices got introduced. They didn't happen out of the blue. Companies invested their R&D and their money into those technologies. Likewise, companies are now also investing money and workforce in future possible tech solutions. So what we are trying to do here in this video is trying to align DevOps skill sets or DevOps future skill set requirements with those technologies. So the first tech that we are going to talk about, well, it has many names, but we'll refer to as function as service and serverless services. As the name suggests, it's serverless means it does not require infrastructure. So when your application can be hosted without you having to own a server, that is where we call something as serverless. Now, function as a service is different and software as a service is different. So don't confuse those two terms. Those are two different terms. A function as a service is not new. People are already using it, but it is not being optimized, used to its full potential. You have market leaders like AWS, Google, and Azure already providing certain services which tap this potential. So how is this different from traditional software development? Let's paint a picture. So this is your code which you have written, which might be a new code, might be a new cool idea that came into your head. How do you show it to someone? So you either install it on a server or maybe just install it on your laptop and then give a demo to somebody and show him how the cool idea translates into business logic. Now this guy here, he likes what you have shown him, and he says, okay, give me your piece of code and I will show it to somebody else. So this guy likes your code and he says, yeah, this is cool, this might work, so ship it to me and I will demo it to board of directors or some potential customers. Now you're not going to ship your laptop to this guy, right? So you will form some kind of package or some kind of executable for this person. And this is where containers became really cool tech, because you were able to wrap this piece of code inside a container and then give that container an executable as an executable for the people, and they can install it on their systems and then show it to other folks. Now this is cool, but this is still one more layer on top of what is needed. You just have written some piece of function, right? You have written some piece of code, and this guy liked your piece of code. He just wants to show that code in a different environment to other stakeholders. So why should he bother about containers and pods and VMs and all of that stuff? It's an overhead. Now let's take an alternative route. Say if you were able to deploy this piece of code. Now let's say if you were able to deploy, or if you were able to host this piece of new tech as a function, and you call it my function or new function, and this new function is now accessible by common communication devices, by laptop, internet, browser, mobile, anywhere. Anything which has a connectivity can reach out to certain URL where you are hosting this piece of code, this piece of tech, and this person can reach and see what the cool tech is all about. So he can also make other folks use the same URL or demo it without having to have any layer on top of the code. So whatever you are writing as a function can directly be shipped. There is no infrastructure here. In a way, it's dangerous for infrastructure engineers, DevOps, because when there is no infrastructure, what will we manage? But we'll come back to that point later. But just think about it. You just wrote a piece of code, and this code, as soon as you compiled it in your system, in your dev environment, this dev environment automatically can turn into production. There is no pipeline here. There is no hassle of maintaining the infrastructure and having different juggleries to be done so that you can at least demo it to other folks. This is very powerful, and this is one potential tech that is still underutilized. So from the services in AWS, I'm choosing AWS just because it's free to use as an example, but Google also has it and Azure also has it. So let's create a function. Let's say my lucky number, and you have different languages which this service or this function supports. Let's choose Python, and this is the architecture type, whether you need Intel or AMD base. We'll go by the default selection. We're not touching much on the permissions. So as soon as this function, what it gives you is a source code or a code source, what they call, and that is this part here. So this is not meant for DevOps engineers now. This is meant for development. So you will do your core development in this section. So let's say I had a brilliant idea, or I have some kind of a algorithm which if you give your name or if you click on this link, you get a lucky number. For me, let's say that number is 7. So I've written my piece of code, and this is my logic. What you have to do is you have to test it first. So let's create a test environment. Let's go by default name, my test env. We don't really bother about the event JSON. So changes are not deployed. Let's deploy it. Now, what we have done so far is that we used this function and we created a Python class which is called lambda function.py. And this lambda function.py is executable from this environment, right? Now, I want to show it to the third person. I want to show it to my manager, or I want to show it to my stakeholder and say that, see how cool I have created this new application which gives you your lucky number. I'm not going to go and take my laptop and show it to that guy. What I'll do is I'll use one trigger, and there are multiple triggers. You can call this function or call this Python class from even IoT devices like Alexa, or there are multiple options. That is not the point that we want to cover in this video, and I'm also not endorsing lambda function of AWS or Google function or Azure function. What I'm trying to show you is how this works. So what you have to do is you have to create API gateway, and let's create a new one. Let's say I want this to be executable for HTTP API calls. Security, I'm not bothered about right now. So you saw one cool thing here, that even you can provide a security parameter at your API endpoint without actually doing anything. Just select JWT authorizer and you have the security. But that's not the case. We are going to go with open security, and I edit. I get a URL, an API endpoint. Now, as soon as I hit this API endpoint, what is happening here? My code is actually live, hosted, and anyone in the world who has access to this endpoint can execute this function. Now, this is a simple example, right? But think of it from a software development perspective. As soon as you are happy with your tests and you know that your application is shippable, ship ready, there is nothing else that you need to worry about. You can directly go and deploy your function. Now, if I want to show it to somebody else, let me use an airdrop, select that person, accept it, done. And what you see is that even on other devices, real time, you can share your function. Doesn't matter if it's a mobile phone, if it is a laptop, if your underlying function is HTTP and you're using a browser, you're ready to go. So that is the power of function as the service. No DevOps engineer is needed for this piece of code to go into production. This is actually very scary, to be honest. So if no DevOps engineer is needed, what will DevOps engineer do in this case? That brings us to the second point. So what will DevOps engineer do if there is no infrastructure? Well, we are going to focus our attention towards AI and ML driven CI/CD. Like I said in the introduction of this video, in the simplest form, DevOps is automation of your CI and CD pipelines. Now that automation will be enhanced by machine learning and artificial intelligence. Now, what does this mean, AI and ML driven CI/CD? Imagine if you're making a change in your function. Let's say this guy, you shipped the version v1, and now you want to ship the version v2. And while you're running your test, everything is fine. Your pipelines or your tools, well, let's call them tools. So your tools have the intelligence to tell you that if you deploy v2, you will see this problem, or you might encounter this network blockage. This is again not something new. This is people are working on this pretty heavily since last couple of years. In fact, there are vendors who are providing this also as a service. So don't be surprised if you see somebody already using this in their production pipeline. But this is AI and ML driven CI/CDs are not that common, and this is going to be key tools or key skill set knowledge that DevOps engineers of the future need to have. First of all, let's try to understand what this means again from a pictorial representation point of view. So here, when you were trying to deploy v2, you will have certain thresholds, right? So you want to have certain thresholds, maybe in terms of latency, in terms of security, in terms of compatibility of this function with other services that can be using this function. Now, AI and ML, they work on previous experience of the data. So the data that has been there or that was generated from the previous executions provide the intelligence to the system. It's similar to, like if you're cooking something and it's a new dish and you don't know how much salt or how much pepper to put in to this dish, you quickly go and call your mom and ask how much of the spices have to go in, and she will tell you, yes, this amount is fine. Now there are two ways to do it. You put this spices first and taste it, and then you make that judgment whether this was screwed or not, or you rely on the intelligence of your master chef. That is exactly what is going to happen in technology as well. There will be no deployment which can be reactive. All the deployments that we do right now. I won't say all, but most of the deployments that we do now, they are done as a result of continuous enhancement to the test cases of other environments, like production like environments. So you do your testing in QA environment, then you do it in your stage environment, then in your pre-prod environment, and then eventually you release a code in the production environment. But you cannot test it in the production environment before it is actually deployed, right? So that specific pain point is what is going to be targeted, or that specific problem is what is going to be resolved by this particular future tech. So there will be tools in future who can predict whether a particular version of a software should be deployed or not, whether a particular version of a software is susceptible to cyber attacks, susceptible to latency. So what are the tools that you can look at in the present day market scenario, which are going to be the masters or be the market leaders in this particular domain? So again, AWS has something called AWS DevOps Guru, and has very simple use case. This is, again, I won't say this is a mature tech, but of course, like we are discussing for the future, so this is something that you should definitely invest your time in. Try to understand which are the tools that are AI and ML driven in their thought process, or which are the organizations who are investing their energy in AI and ML for the CI and CD pipelines. Another tool I would recommend is to Epsagon. I hope I'm pronouncing that properly. Again, this is AI and ML driven DevOps tool for CI/CD pipelines, which will be able to tell you even before when you are not even deploying. It will be able to tell you how your future results of the deployment will be. One more key aspect to this AI-driven CD is self-healing or rollback. We see some form of it already existing in Kubernetes, but this is, again, very, I would say, young in terms of adaptability. In the coming decade, or not even decade, in the coming few years, this is going to be self-healing capacity of your production environments is going to be a key component for your success. So if you know any tools which are good for self-healing, like Kubernetes, I gave you one example, definitely go and invest your time in AWS Guru. Amazing service from AWS. Again, I'm not promoting them, but it's a very awesome service to know. And Epsagon, great product. Then Tetrate is also making a very good progress in terms of having the artificial intelligence in the networking domain of your services. So what kind of networking issues you might face with the future version of your traffic, of your function, is very nicely explained by Tetrate using STO. Another future tech, which is again finding a good foothold in the present day market, is the strategy of hybrid cloud. You will find a lot of people wanting to have their infrastructure distributed throughout all of the vendors, and you as a DevOps engineer should know how to manage the hybrid clouds, how to manage the services, the functions, and how to host them in hybrid clouds, how to create the pipelines, how to create, how to deploy, how to first build your code that in such a way that it can function on all of the vendors. That pretty much we already know. That's not a problem. We already have the knowledge for building codes which are platform agnostic. Then how do you deploy them on different vendors? Again, application, you follow infrastructure as code principle here. So you use services, you use tools like you use Terraform, you use SaltStack, Vagrant, Juju. all of those can support multiple cloud vendors. So invest your time in understanding, if I have a piece of software that I can deploy in AWS, how can I deploy the same piece of code in say for example Oracle Cloud or Google Cloud without having to have a wrapper around it or change a lot of my code there. So you will also have to understand here what is a hybrid virtualization, what is a hybrid containerization, and a hybrid serverless service. I know that's a mouthful, but this is also going to be key. Your virtualization, I have created a separate video on virtualization and containerization and how they are different and similar in some aspects. I will link that somewhere in the video. You will have to identify those tools which support the hybrid virtualization, or which can enable hybrid virtualization, hybrid containerization. Say for example, you want to use multiple different container engines in a same server. How can you manage your DevOps activities in that use case? If you want to use, like here we saw the demo of AWS, say there is this function that was running in AWS, and I have created another function here which is running in Azure. And now this function F2 and F1, this guy, they have to combine, or they have to call each other and work together in order to provide a feature to the customer. So in that case, how will you manage the CI and CD between these two functions which are hosted on a hybrid serverless service? After hybrid cloud, what we should focus our attention is on augmented and virtual reality. First, we have to understand what is the difference between augmented reality and what is the difference between augmented reality and virtual reality, and what is the tech that these two technologies are going to drive. Now, you might recall from some years back, there was a very popular game called Pokemon Go, and you might have seen people, holding their cell phone and running here and there. So what that game was triggering was this piece of tech, argument. So it was taking the entire landscape of your current reality, and it was argumenting certain virtual elements within that reality, and it was not changing your peripheral of the existing reality, but it was adding the augmented objects on top of this. Now I believe that education is one particular section which is going to have a huge impact, or which is going to have a huge usage for augmented reality, where the future of teaching is going to change, and the future of teaching is going to be driven by the augmented reality. You will be having augmented labs or augmented examples taught to even toddlers. I mean, not toddlers, at a very young age people will be introduced to augmented reality, and augmented reality is going to be education or edtech driven. Then comes virtual reality. Virtual reality is where you actually change the peripheral of the user itself. So this is where Meta, Facebook company, is heavily investing their technology or their resources. So here, who is going to use this, or what is the future for this tech? It is mostly going to be used for entertainment and pleasure purposes. Your movie watching experience, your game playing experience, or in fact your shopping experience might be driven by the virtual reality of metaverse. Now, what are the tools that you as a DevOps engineer should know for this particular future tech? So this is in future, so we still do not have any prototype to say like this is what you should use, but it is a safe bet to say that these are going to be embedded systems, or these are going to be mobile tech driven technologies, and we already have certain companies who are heavily investing in a DevOps for mobile driven or DevOps for augmented reality driven technologies. Now, which are those tools? Now, you should start looking at what Bitrise is doing. You should start looking at what App Circle is doing and what Build Plan is doing. These are companies which started with the DevOps portfolio for mobile industry, but they are now shifting towards AI and also towards augmented and virtual reality driven tech. So this is a safe bet to say that a lot of job opportunities will be there in this particular future tech. Of course, the traditional DevOps of having on-premise services, on-premise servers is not going anywhere anytime soon. So just don't throw out those Ansible playbooks or Salt Stack books. They are still going to be useful, but if you want to stay if you want to stay one step ahead of the competition, or if you want to stay employable throughout the coming decade, then these are my four pick of technologies that are going to drive the future job business for not only DevOps but generally entire IT domain. And knowing them, using them is possible at the current state, maybe in bits and pieces, because some of them are not yet that mature. But some of the examples which we saw today, you can just go through them and try to understand what you can with their current state. All right, that's all for this one, and I hope you learned something new today. If you did, don't forget to share it with your friends and network, and I will see you in the next one.